Good morning, good evening. My name is Yesun-Erdene. I am studying computer science in University of Trento. Here I am presenting my project that I have done for the exam of the course Computer Vision. So my project is about analyzing archers' body posture to provide information that could lead to automatic method for evaluating body posture and classifying it as proper or incorrect in the future work. This project is proposed by myself. The motivation has come from the real life need. So, what's the problem of archers? We need someone to monitor our body posture, especially when we are training without our coach supervision. Why do we need to monitor? The archers tend to make incorrect posture because of heavy bow. As you can see in the picture, there is the long heavy pipe, which is the stabilizer of the bow, and holding it only with one arm causes inconsistent posture. And it's hard to monitor our body while shooting because we cannot focus on aiming on the target. Even some body parts are cannot even noticed by the archers themselves in practice. Why body posture is important? Because it influences our body balance, which will affect the shooting performance. Also, to prevent from injuries such as muscle fatigues, spinal and lower back pain that caused by inconsistent incorrect posture for the long term. So I did a bit research on works that has been done in archery field in the past. For archery, there are very limited number of works have been done on analyzing body posture of an archer. I found that the most of the works used markerless and deep learning approaches, such as the first two papers on the screen, and they both used deep learning for analyzing the archer's joints. The most similar work to what I have done is this deep learning posture estimation for archery consistency measurement. It was done on posture images processed with a deep learning pose estimation model to study relationship between postural consistency and scoring performance using an automated posture estimation mechanism. However, no work has been conducted on analyzing body posture with purpose of distinguishing between correct and incorrect posture using a marker-based system. So, how did I implement my project? Here I focused on analyzing key posture joints such as shoulder, spine, hips, and feet, those that affect the body balance and performance. Then estimated joint tilting angles and distances between key points. These analyses compare correct and incorrect postures by estimating the joint angles and distances. To collect data, we used motion capture technology to capture postural parameters. So me and Julia, we collected a data set by recording using the OptiTrack where I am doing the shooting postures with bow equipment. So we obtained one correct posture that is used as reference and four other recordings that are showing the incorrect postures around the shoulder feet distance and hips tilting to the right and the left side. I only focused on body posture rather than studying the correlation between body posture and shooting performance because we didn't record the shooting phase. So the main analysis has been done on estimation of the joint angles and distances. From my data, I was able to extract the marker positions so that I can build the joint vectors from those marker 3D positions. Then I calculated the angles between joints using the joint vectors and also calculated the distance between points. Then finally I compared the angles and distances that I measured between the correct reference posture data and incorrect postural data. So in this case, I analyzed shoulder raising angle using the arm vectors and distance between toes and feet. Then analyzed tilting angle of back leg by computing the angle between leg vector and the vertical plane. Then analyzed tilting angle of spine by computing the angle between spine vector and the vertical plane, and also hips raising angle by measuring the angle between hips vector and horizontal plane. Finally, The hips dropping unit, which is calculated by computing the difference between coordinate in vertical direction of hip points. To mention, the fingers were not included in the estimations, they are only for illustration purpose. So finally, the result of the analysis shows the significant difference between the correct and incorrect body postures. We can see the differences in detail from the graphics. In the graphs, the green line indicates the correct posture values, red and pink lines shows the incorrect posture values from the data. From here, we can see that the angle value decreases as the archer raises the shoulder more. The correct value of the shoulder remains over 140, but incorrect shoulder angle is shrunk down to 130, especially during the aiming phase. So the shoulder must be more straight. For feet, here shows the distance between feet and toes, where the correct distance between feet is within 27 or 28, while the incorrect distance exceeds over 40. So generally, foot distance should remain within body overall width. For hips analysis, as we can see more, the archer tilt to one side. This metric will make bigger differences. When the posture is completely correct, the two hips are in horizontal straight line, so the difference is zero. Otherwise, it increases more. For back leg analysis, the leg tilting angle increases as the archer tilts to one of the sides. The correct posture suggests to stand straight on the legs. But for spine analysis, it's noticeable if the archer is tilting only to the left side, where the angle difference is bigger. The correct posture suggests only slight angle on the spine to vertical plane. The hips raising angle shows actually very limited information compared to the other criteria. To conclude, this project shows the importance of monitoring posture as a basis for consistent performance in shooting and injury prevention. Also, it shows that it has the potential to provide a basis for the future work to integrate posture analysis with shooting performance evaluation. And thank you for your attention.